Ever tried asking a question on a bunch of documents only to get partial information or nothing at all? It's frustrating. Not getting the clarity that you want or riddled with more questions and confusion. This is because all the AI agents use the same simple RAG approach. They take web pages or PDF documents and flattens them into a single text blob, losing lots of structural information like sections, tables, images, and other visual markers that convey important information about how the document should be read. What if there is a way to keep all the structure intact, or at least some of them which are important for a general purpose question answering use case? Let's explore a better way to get answers from AI agents using document knowledge. Let's look at the current way to index documents for a simple RAG approach. On the left, you can see there is a research paper document which has text, images, tables, and a lot of structural information about different sections that we want to use for question answering purpose. In the traditional approach, this document gets converted into just text blob, as you can see on the right. When you try to retrieve information from this, the results lack the original context and structure. Because of this, the answer that the AI agents give feel less comprehensive and not that helpful. It doesn't have any tables, images, section hierarchy in the document or other structural information. In the new approach, instead of treating a document like a single text file, we break it into logical sections. Think of this research paper, and it has titles, abstract, methodologies, results, conclusion, and different sections. Our approach identifies these sections using heading markers like H1 and H2. Here you can see on the left, there are sections at the title level, at abstract level, there are images, and there are tables. Each of these are extracted separately and associated with the corresponding section and allocated a unique section ID as well. Once identified, we generate a structured JSON format where each section is an object containing three possible elements: text, tables, and images. Some sections have all three, while others might contain one or two. Once we've structured our document, it's time to index them. And we do that based on their type. Instead of dumping everything together, we store and later retrieve data intelligently. Text segments go into VectorDB, like VV8 or Quadrant, for semantic or hybrid search. Tables are stored in SQLDB, like SQLite or Postgres, allowing SQL-like querying that is more accurate to extract useful information from those tables. And images are extracted from the documents and uploaded to cloud storage like AWS S3. Along with the main content, we also save a reference to the original section that they belong to. For this, we assign a unique ID to each section in the original document. This will ensure that text, tables, and images are all linked together at the section level. So when we search later, we don't just retrieve text, we get relevant tables and images as well. So how does this search or retrieval work? It's a simple 5-step process. Given a user question, we first run a semantic or hybrid search on the VectorDB to find relevant chunks. Based on these chunks, we identify the sections linked to those results using unique section IDs. For each of these sections, we find other relevant text, tables, and images. Next, we do a secondary query on the tables associated with those sections by translating the original user question into a DB query that is aligned with the schema of the table. Finally, we merge all of this extra information corresponding to that sections and send it to LLM to generate a much more comprehensive and helpful answer to the user. No more partial or confusing answer. Now you can get a fully organized and data-rich answers. We believe that this approach will drastically improve the document search and retrieval process. Imagine using it for research papers, legal documents, business reports, finding exactly what you want in the format that you expect. So what do you think about this approach to improve document question answering for AI agents?